So welcome everybody. Thank you very much for joining. Today's session is dedicated to a holistic approach in monitoring and managing broadcasting workflows, because it may not be a trivial and a simple task. A lot of equipment and content specifics and industry standards are involved in the overall delivery chain for live TV. And specifically for managing this complex system and controlling the quality of the end-to-end video delivery, there are monitoring tools on the market. And we are presenting today a synergy between two of the most powerful tools in the market, Elecard Boro monitoring system for audio, video, quality of experience and quality of service parameters control, and DataMiner by Skyline Communications for overall device control and general troubleshooting automation. And a couple of words about our speakers today. So we have Thomas Gunkel from Skyline Communications. He has more than 15 years of experience in product marketing and solution design in broadcast and video environments. He works for Skyline Communications. Welcome, Thomas. Thank you very much for helping me and
Thanks, today. Alexei. It's my pleasure to run this webinar today with you. Thank you.
Thanks a lot. And about me, so I'm working for Elecard for more than 6 years right now, working mostly with the delivery for TV operators and broadcasters in complete turnkey projects for OTT, IPTV platforms and live streaming. So let's go to the session schedule. Today, we're going to cover Elecard Boro solution overview and key metrics, which are worth paying attention to during your monitoring of the broadcast environment. Then we will switch to DataMiner platform introduction and the benefits we were able to achieve when merging these two platforms together in our integration and partnership. And then later on, we will summarize the benefits of monitoring and turnkey monitoring for media and broadcast and direct you to the live demos and instruct you on how to get started easily with our solutions. So about Elecard company, a few words. The company was established in 1988, so we have more than 36 years of experience in digital video. We're working with the technology companies as well as with the broadcasting companies and telecom operators like Netflix, like Walt Disney Company, like Fox, EA, Globecast, and many, many others. Today in our portfolio, we have our own SDKs and all of our solutions are built on using our own in-house components. We're also providing turnkey solutions for video real-time encoding and streaming, quality of experience and quality of service monitoring, and video quality analysis in-depth tools. And one of the youngest products of ours is digital signage orchestration platform, Elecard Icon. But today's session is dedicated to quality assurance for audio, video, and Elecard Boro solution and DataMiner integration. And also a couple of words about DataMiner and Skyline Communications, Thomas.
Yeah, Skyline, as you see here in this slide, we are about 350 people. One company, our headquarters is based in Belgium. We have a couple of other larger offices around the world with a presence in more than 20 countries. And all we do is a single product, which is called DataMiner. DataMiner, in essence, is a platform for monitoring, for control, for observation, has an automation orchestration engine built in, but we use it also a lot to plan events, work orders, jobs, and to also deploy infrastructure when you think of cloud-based infrastructure. And we focus on the ICT media broadcast industry together with some broadband platforms. On the next slide, you see a bit on our customer base, a lot of joint customers we have already with Elecard. In essence, we have more than 1,500 users across the globe. To give you some other numbers, we talk about more than 10,000 DataMiner systems we have deployed over the last 25 years. In terms of connectors, this is integrations with third-party infrastructure systems and databases, many thousands from more than 1,000 different vendors. Thank you.
And back to our main topic of discussion, so setting a problem. Broadcast systems are quite complex with a lot of equipment involved in the video processing chain, and even a minor problem can significantly influence viewers' experience. And that's what the monitoring systems exist for. They help managing and localizing the issue sources in the overall delivery chain. And so Elecard Boro is one of such systems. It was designed as a distributed quality control system with the client-server architecture. You have a central server and the probes, which can be distributed across the entire delivery network, sitting on the ingest point after transcoding, after packetizing, and on each and every CDN edge to allow you to control the deviation of the quality of experience and quality of service parameters and quickly localize the issues and find the issue sources. So for example, the content may, from the source, it has a long journey before it plays back on the viewer's device across transcoders, packetizers, and different, maybe even multiple CDNs. And of course, the parameters of the content may deviate, the packets may be lost, or some other important parameters may be broken. So, and Boro helps localizing the issues and alerting the responsible engineers, triggering corrective actions, and providing detailed logging and detailed information about the issue sources and possible reasons. So it's also important to present in a readable form the data about what's happening in the stream, and Boro has a user-friendly interface. So this is, for example, the live view, where you can access the information about the streams in a user-friendly way with color-coded images, where the states of the streams are represented with colors. And green, everything is okay, red, something is bad, and other issues depicted with other colors, like yellow and orange. We also have a dedicated page for fine-tuning the settings and thresholds for all the controlled parameters inside Boro, including Ethernet parameters, HTTP streaming, IPTV, etc., etc. I will cover them later. If you have dozens and even hundreds of streams, it's convenient to place them on a single window to control the overall health of all the streams in one single place. So this is the block view, where you can aggregate the information about hundreds of channels on one single place. And if you need a deeper insight, you can go to the task page, where you can see all the detailed logging of what is happening with an individual stream, and also the graphs for each particular parameter, which is being monitored right now for this channel. We're also introducing a KPI view, which allows making availability trends for each particular stream based on the total number of errors received for this stream. So this is a general service health page. And going to the next section, we wanted to give you more details about what stands behind the distributed monitoring system notion. What does it mean to have a distributed monitoring system? And we will present the key metrics which we think are important to monitor at each location in the video delivery chain. So here we grouped the parameters according to their location in the delivery chain. The first group is contribution parameters. The second one is HTTP distribution parameters. We will talk mostly about OTT. This is the most popular delivery way now, gaining traction on the market, and it represents a challenge for many operators right now to fine-tune the overall OTT systems in their premises. Also, we'll talk about edge streaming parameters. And a separate group is DPI, digital program insertion parameters. It may be advertisement insertion or local content insertion on regional stations or something like that. So let's go to the groups parameter by parameter. So first, you want to make sure that on the input of your headend, you have a coherent stream. Right, and you need to check general TS integrity by TR101 compliance and internet parameters. So for example, here we have a complete check of TR101 to 90 conformity in Boro. You can check the timestamps continuity, you can check the synchronization of TS packets, you can check the metadata and tables, and you need to verify that your content provider is giving you a healthy and coherent stream. Also, there are Ethernet parameters allowing you to control the health of your network. right? And configuration of your equipment. Then, of course, SRT protocol as an ingest protocol and contribution protocol right now is gaining traction also on the market. And we understand the clients' needs to monitor it more precisely and more in detail. And we introduced in Boro more detailed statistics about SRT. So right here, for example, you can see that we are tracking the total SRT packet loss and also packet drop. Packet drop is the parameter which depicts the number of packets which the receiver decided to drop because they were not correctly received or were not correctly decoded, for example, right? And you can see these, the aggregated statistics. Also, we have a dedicated graph for SRT retransmitted packets here. So you can see the total number of packets which are being sent by the SRT sender and how many packets have actually been retransmitted to recompensate the data loss. Also, it's possible to check the different SRT bit rates, including the bit rates for the retransmitted packets and overall transmission. Also, it's possible to check the available bandwidth in the connection to the content provider. And also there is a metric for SRT delays, giving you an understanding about the round trip time between the sender and receiver. All right, so this is the contribution parameter block. Of course, there are much more parameters. This is just something we wanted to highlight. And in the HTTP distribution parameters, usually it's important to look at the parameters related to variant streams, manifests, segments, and also to the quality of experience parameter specific for OTT delivery. And the variant streams delivery, it's possible now to track the variant stream switching when, for example, the bandwidth dropped and the player had to switch to a lower bit rate. Also, important parameter might be the bandwidth missed in variant stream. This error represents the state when in the variant stream, there is no description of the bandwidth of the profile which is being broadcasted. And in this case, the player might not be able to actually ingest and play back the stream correctly. Regarding manifest section, there is a static manifest error, which relates to the state when the manifest is not being updated properly and in time and in timely manner, which may result also in the stuttering and the playback issues. Manifest error corresponds to the error inside the manifest itself. For example, there might be some incorrect links to the segments for the OTT delivery or the links to the media playlists inside the master playlist, which will also affect in a bad way the overall stream distribution and playback. For segments, it's of course important to look for the segment download failure. For example, when the bitrate is too low for the segment to be downloaded by the end user and the playback device just decides to drop the segment completely. And segment loss, when it was impossible for the end client to actually access the segment itself. And of course, OTT quality of experience parameters. It's important that each OTT chunk starts with an IDR frame for the playback device to be able to actually decode the received chunk without referencing other frames, the video frames, which may not even have arrived yet. So that's also important to check. And of course, the video should be in progressive. All right, I'll try to keep it short. And jumping to the edge streaming parameters. So for the edge streaming, of course, you would want to understand from which particular CDN edge the stream is coming to the playback device. And now it's possible to track looking at the effective URL. So this will allow better insight on the CDN delivery characteristics. And also it's important to track the time to first byte. Actually, this is the time between the request from the user to the CDN edge and actual reception of the valuable data by the playback device. If the value of time to first byte is too high, it may affect the viewer's experience badly. And now also the SCSI 35 parameters block. They are like a little bit separate parameters block. They can be monitored at each and every location in delivery network. It's important for the operators to track that the advertisement insertion starts at the right time and the advertisement is delivered properly, and also that the advertisement does not ruin the overall streaming and corresponds to the overall channel characteristics and aligns with the main broadcasting workflow. All right, so this is a quick overview of the parameters block. We will be presenting detailed demos on the upcoming shows, industry shows, including NAB Show. Elecard will have a booth, and our partner Skyline will have a booth, and we will be cross-referencing each other, showing the demos of our solutions on each other's stands. And also the next show, we will be present as well in Dubai for CABSAT. So don't forget to write your questions in the QA tab, and I will then be passing the floor to Thomas for the overview of the DataMiner platform and our integration with them.
Thanks, Alex. Thanks very much. Let me talk now in the next 10 minutes a little bit about DataMiner, the foundation. As you see here on this slide, DataMiner as an open platform has multiple layers, and the most important one is what we call a data collection and control plane. And this is actually the layer where we interface with all the infrastructure a customer has, hardware, software, operating systems, servers, media functions, including probes, Elecard Boro. And there we have built so-called connectors. And when you go to the next slide, which connectors do we have? We have a public catalog. And when you use that link or scan the QR code, you end up right on the Elecard Boro connector that you can download straight from our catalog into a DataMiner system. And that's really the foundation where we can read each and every parameter from a Boro probe, a Boro unit, get it into DataMiner, and also configure Boro again, maybe for alarm configuration, etc. So this is all about reading parameters, configuration, and setting parameters, including that Boro probe. That's the foundation. And once we have this foundation, here you see some details. When it's installed in a DataMiner system, you get like what I call here an engineering view. Every parameter, as I just mentioned, you have available in real time coming from Boro, and when the API allows it, some parameters we can also set and configure. That's the foundation which you have immediately out of the box. All you need is the IP address and credentials for a Boro device, and you can immediately talk and interface with each and every Boro device in your ecosystem. On the next slide, you see then what we call the data consumption. There we have something for the data consumption, what we call low-code applications. Data consumption is typically more custom because each and every customer, they require a bit of a different set of data. So there's nothing like off the shelf because usually that would not fit for all the needs. And what we did instead, we built those low-code applications and allow the customer to build their own user interface with just a few clicks without coding skills. And on the next slide, you see something we have put together for the show in just a few minutes or hours. This is a sample low-code application with some data, most important metrics, including alarm information, etc., coming in real time from an Elecard Boro. And this is typically then used for operations. So we have the connector giving us all the data, and then we can build those low-code apps on top for operations, often a subset of data, grouped slightly different, much more visual than the raw data we get from the probe. On the next slide, then we see what we call the digital twin. And part of that, this is really the result of having that connector and getting all data from Boro into DataMiner. We do monitoring, and monitoring goes along with what we call fault management and service management. And before we look into details, what you see on the next slide is a bit of why monitoring at all, and what does monitoring mean? Monitoring to us is, why do we monitoring? You want to deliver the best possible service quality for your audience. What does it mean? You need to monitor everything that contributes to the health of that service. That's first of all, you need to monitor video, audio data. This is what Elecard does with the probes. And you also need to monitor all the infrastructure that contributes to that service. And here's a very simple example of a simple playout signal chain. You might have the playout server application in software. that runs maybe as a microservice in a container, runs on a virtual machine, runs on an operating system, Windows or Linux, and runs on a Dell or Supermicro hardware platform as an example. So you need to monitor each and every part. We call this north-south monitoring. But then looking from left to right, it's not only the playout server application that contributes to the health of my playout system. I might have a graphics engine, again, very simplified, a subtitle engine, an encoder at the end. And we need to monitor the infrastructure from either the appliances or the applications, hardware and software all together, what we call service monitoring. So we really put a layer on top. Now, where does Boro come into play? Boro is another source of information because DataMiner, we never analyze any video audio data packets. So we require Boro to tell us also about the health state of the video, the audio, the data, SCSI-35, etc., everything you have just seen. And all together, we put that big layer on top, what we call a service layer, to say there are individual, there's an individual health state of each and every device or software application we interface here, but altogether there's another service health state of the overall playout service, and that can be in a good or a bad state overall. For example, a playout service can still be in a healthy state, although the backup is down. So there's different ways how you look into it, but here we look really into it from a service perspective, together with the Boro probes. On the next slide, you see something what we have from the workflow process and automation engine that we use, and you see this on the next slide again. What can we do? Not only monitoring, but once we know that something is probably not healthy anymore, first of all, we always tell to the operator, so there will be notifications via email on the DataMiner user interface. But at the same time, as we have also an automation engine, we can not only detect the problem, but also trigger a corrective action. And that might be a very simple failover by telling a changeover unit or a router to switch from a main playout server in our playout example to a backup playout server. So not only we detect the problem, we can inform the operations, but we can also, if they prefer that, fully automatically fix the problem based on the fact that we monitor everything that contributes to that health state of our service. Then I want to use a couple of minutes to talk a little bit of what we call AI-assisted monitoring, or sometimes augmented operations. When you look into monitoring of today, monitoring is based on thresholds. So you define certain thresholds for certain parameters. You get an alarm if it's above or below the threshold. But when you use monitoring systems, you might know those thresholds are never perfect. If you set them too high or too low, you either get too many alarms or you miss some of the important alarms. And you're always trying to find the right threshold. And especially in a more dynamic system where the parameters are changing in a very dynamic way, you would end up in a constant process to always trying to improve the threshold. So that's not really sustainable for the future. What we have done and started a couple of years back, we added AI, machine learning algorithms to our monitoring for two goals. First of all, we want to inform operations that things might go wrong soon or in the future before they actually go wrong. And second, we want to build a self-learning and zero-touch provisioning system. Means no need anymore to define all those thresholds. So how are we doing this? We are implementing a couple of AI algorithms, for example, for trend forecasting. You see here a trend graph of any parameter. It has a certain pattern. You see some of those peaks, historical peaks there, where we analyze already for anomalies. And if there would be an outlier, you see some of those minor peaks, and in the middle, that yellow rectangle shows a higher peak. That can be an outlier. So that's an indication that something is not quite right. We would inform the operator without defining any threshold. And on the right-hand side, what you see in the dotted red rectangle, that's the forecast. So when we forecast behavior over time, gives us quite a good way to say there is a slight chance that things might go wrong or will reach a certain threshold in the future. And that allows us to throw warnings or alarms to an operator before things actually go wrong. And Alexei, when you think about a couple of parameters or KPIs, I guess there are a lot of examples where especially in a network or in a degrading quality of your OTT service, we could easily inform customers that things might go wrong soon before it actually goes wrong.
Yes, that's true because the thresholds, although they're quite flexible, they will not change the human eye in terms of the trend forecasting, yes, and pattern detection. And when you're going to do this with AI tools, for example, if you even lose the packets, but the thresholds are not met, or you lose the packets like quite inconsistently, time over time, one packet here, two packets there, then the monitoring system might overlook them, and even the human will overlook them, not paying enough attention to the graphs. And that's why, yes, trend forecasting might be very helpful in this, for sure.
Next to forecasting, we do other things like pattern detection, as you just mentioned, relationship learning, grouping parameters together that might have a certain relationship. We also do alarm grouping, especially in the OTT space when the root cause is somewhere, maybe in the studio where you lose a signal, you get thousands of follow-up alarms down the signal chains. And in the past, you were using like manual correlation rules to group them all together and say, yeah, the root cause is likely somewhere up there. Now with AI, we can group those automatically together. And instead of having hundreds of thousands of alarms, we reduce that to a single alarm group. And here you see another very interesting one in my eyes. That's what we call flatline detection. That's also an AI feature, often for systems that go into freeze. You have a lot of parameters, network parameters, CPU, RAM, to give some very simple examples, that are constantly changing. They're never flat and steady. But when they are steady once and flat, that usually means something is frozen or it broke. And imagine you have to do this with a static threshold. There's just no way to identify a parameter that is not changing anymore. Using a bit of machine learning, you can easily identify those as well.
For something, there could be like a static error trigger, but for some parameters, indeed, the static state is not considered the threshold over.
And once more, very important, what you see here, like forecasting, that flatline detection, is not something you need to configure. You just start DataMiner, interface with Boro, establish the connection there, and from that onwards, we automatically start analyzing the system, the behavior, and the behavior over time. And to summarize it, why do we need monitoring? What is it about? When we talk monitoring, we always say it must be deeply embedded into the operations nowadays. In the past, monitoring was a bit of an afterthought. It was always a separate system. It did not have any context. We say monitoring requires context. To give a very simple example, when you have a non-permanent channel, an event channel, the monitoring system should better know when the event channel starts and stops. Otherwise, you get tons of errors before and after that, when there's probably no signal up and running yet. We are heavily convinced in a more dynamic world, we need assistance of AI, machine learning algorithms, to make your monitoring more proactive rather than letting the monitoring system detect issues when it's already too late. And as we have learned with static thresholds, that's really a challenge. In summary, that means monitoring needs to follow resource and service lifecycle. We need to know about the schedule of events. We need to know about when certain things should happen. That can also be interfacing with a playout system, as an example. When we read the playlist and the playlist tells us when a SCSI event should be on air, then we compare it with the SCSI triggers Boro receives actually when they are on air. And with that, we get a perfect correlation between when should things on air, when they are actually on air, and we can immediately identify mismatches. And last but not least, monitoring, as we said, doesn't stand on its own, often goes along and needs to go along with control. The simple example we had before was a corrective action. We can identify the problem. We also want to fix the problem. And there you need control capabilities to automate that process. Thank you.
Thank you very much, Thomas. And that's what exactly we're trying to do when in our synergy between our two platforms, our two solutions, is that we're trying to expand the context, yes, for the operational teams and broadcast and operators to be able to aggregate all the information, as much as possible information in a single window, yes, to allow corrective actions and to allow them to be more informed about what's happening in their network. on the device level, on the resources level, as well as on the audio-video quality level. Once again, yes, wanted to draw your attention that both our companies will be exhibiting at the NAB Expo as well as CABSAT Expo in Dubai. You're very welcome to visit our booth there. You can contact us with the contact information presented on the screen right now, or you can go directly to the live demo instances and visit our website. So thank you very much for your time today. Yes. So we will be concluding this session on that. Thank you very much.
Thanks very much, and probably see you at NAB. Thank you.
Definitely, definitely.